Hey, thanks for watching this video. This is one class from the 2022 HVACR Symposium in Claremont, Florida. We have the symposium every year, and so to find out more information kind of upcoming, go to hvacrschool.com/symposium. Big thanks to our sponsors for this event, which was AccuTools and TrueTech Tools. They're the two title sponsors that made the event possible. This class is with John Chavez. John Chavez is a past guest on the podcast. He's done a lot in the ductless and VRF space. And in this class, he talks about some of the very basics of VRF for people who are interested in that segment of the industry.
Good afternoon, everyone. Thank you for coming to the class. This class is Introduction to VRF, Variable Refrigerant Flow. And I've spoken to a few of you here. By show of hands, who has installed a VRF system previously? All right. What about service? Okay, right on. Cool. Okay, this class is non-commercialized as much as we possibly can. I'll answer any of your questions, so I may bring up some products, but this is a discussion just about the technology in general. My name is John Chavez. This is a little piece of my resume, but I just want to call attention to these areas here. So I've been a ductless aficionado for quite a while, and anything to get me out of the attic, right? Anything that can get me away from sheet metal, and meat hooks. So I fell in love with this technology pretty quickly and went from, as a contractor, went from 90% airside to 90% ductless in 1 year and never looked back. I'm here in the capacity of a licensed HVAC consultant. So during my time as a consultant, customers call me for problem projects, exclusively. So that was kind of my niche. Imagine you having the most vexing, problematic, angry customer, 2, 3, even 4 years in. Manufacturers called me, owners call me, attorneys have called me, architects. So it's kind of a special niche. Just to let you know, you're in good hands today. Here's some of, these are all guesstimates, I don't know how accurate it is, but I've represented in the capacity of as a manufacturer's agent these products. So I've had factory training from the factory, not on the contractor side. So feel free to ask any questions during this presentation. We got plenty of time. And anybody on LinkedIn, you can find me here. And we can continue. I love talking shop, so you can always just shoot me a DM or what have you. All right, today's discussion topics is what is VRF, VRV technology. We'll talk about some of the manufacturers and key differences. What are the essential features, right, of VRF, variable refrigerant flow? How do they work? We're going to review the components, applications, and design advantages. It's going to sound a little sales pitchy, but don't worry, I'm not trying to sell you anything. If anything, I'm just trying to sell the concept. And then service and maintenance. So there's a very short section on that just to get a general overview. Typically, I give this class, this discussion for people that are not even in the air conditioning industry. All right, so VRF technology, right? We're used to understanding that you can hook up multi-zone systems with one outdoor unit. And I got to tell you, it's not your typical heat pump. And they're all heat pumps. The capabilities of some of these systems are extraordinary. You can achieve 100% cooling capacity down to maybe negative 10 degrees, maybe even negative 20, and have maybe 78% heating capacity down to negative 13 degrees. There are some that can go 100% heating capacity. That's without any supplemental electric heat. This is just heat pump. Usually if you've been in the industry, that heat pumps usually fail. That's a lot sooner than these numbers. And just to, I like to simplify things as soon as I understand them. I find that people like to make things more complicated than they are. Me being one of them, if you ask me what time it is, I'll tell you how to build a watch, but I'm trying to refine that. And this is one of the refinements, It's just software driving the hardware that you already know. Does that help? It's just software. We're going to talk about the software a little bit, but, it still has a compressor. It still has solenoids, expansion valves, accumulator, temperature sensors, pressure sensors. So just a little background here. The first installation for VRF was approximately in 1982. And I think this number's low, actually. It's hard to get a good number, but there's more than 10 million installations worldwide. As a matter of fact, in third world countries, mini splits and multi-zones are almost 100%, maybe like 90. Nobody likes to say 100%, but 95% of how they get heating and cooling. And in Europe, the adoption is something like 85 to 90. They call it chiller killers over there, because in the 90s and the early 2000s, chillers were going out the door and VRF was coming in the door. And in Asia, it's 85, 90%. You can actually go in some third world countries and buy your milk and bread and a mini split all in the same place. So if you're worried about adoption, this is a brand new subject. You're not sure, about it. You don't know if you want it in your, if you don't want to suggest it or recommend it. In 2012, ASHRAE, the American Society of Heating, Refrigeration, and Air Conditioning Engineers, which is our main institution, published Chapter 18 on variable refrigerant flow. And they've if you know, the ASHRAE publishes these books. There are 4 books, and there's a new one published every year, so it's a 4-year adoption. And you can go find it. You could read it online. I think there's actually a PDF available in there, so you don't have to buy the whole book. But if you wanted to, learn more about it, and instead of watching cartoons and eating cereal on Saturday morning, maybe you can understand more about the VRF technology, because that's this, our industry is going towards inverter-driven compressors. And so the more you can understand that, the do's and don'ts, tips and tricks, the better off you'll be, and potentially have some earning power. Because if you don't know, then you're either going to make a costly mistake, or you're not going to be able to talk about it, and your competitor will. All right, so for me, how I like to learn is the words, right? What are the buzzwords? What are the key words? And that helps me understand whatever subject matter I'm having to be learning. So we're going to go over some terminology, not too much, but just enough so we can all be on the same page. So the first one is VRF versus VRV. There is no difference. It's exactly the same. It's just a marketing term. And VRV stands for variable refrigerant volume. And there's one specific manufacturer who utilizes this terminology. But it's exactly the same as variable refrigerant flow. Okay? And we won't go through this whole list, but the second one there, EEV and LEV, there's one manufacturer that uses LEV, but it's an EEV. And by the way, if you go to my LinkedIn page, you can download this presentation. So, yeah. There's really nothing here that is not already publicized out there, widely available. I just kind of collated it. heat recovery. That's how you get simultaneous heating and cooling. We're going to go over that in a section. And then the variable aspect is, equals modulating. You can see the modulating compressor, an EEV is a stepper motor. It modulates. Fan is a BLDC motor, a brushless DC motor. And you could have a multi-speed indoor fan. Here's some other basic terminology, which we'll go over the single phase and the three-phase outdoor units. But in our industry, they call mini splits or single zones, ductless, duct-free split, DFS. In Asia, they just call it a split or a split klima, So, and then a multi-zone or a multi-head can typically, this is in a residential application typically, not commercial. You have maybe 8 to 1. 8 indoor units can be attached up to 8 indoor units to 1 outdoor unit. And then you have branch boxes. So the system architecture. So this is just a general overview of a narrative and how this system operates in very general terms. So just look at it this way. A system of singular or modular heat pumps, more than one, with indoor fan coils which are connected by a common system of control and a common set of refrigeration piping. So common control, common, basically this is a typical diagram of a heat recovery system. It gives you a very good kind of illustration of that. The refrigerant is passed through a series of fan coils by means of a variable speed compressor and metered by an electronic expansion valve that regulates refrigerant flow to accommodate the comfort set point for individual zones. So basically, when you look at a multi-zone or a VRF system, each indoor unit is a single zone to the outdoor unit, right? Each indoor unit is its own zone. The variable speed compressor increases or decreases the system capacity to satisfy the individual load requirements, resulting in lower electricity consumption. So if you have a high load in a space, the compressor is going to ramp up, deliver refrigerant to that indoor head. Indoor head will satisfy the space. As soon as the space is satisfied, then the compressor will ramp down. The refrigerant into that coil will be reduced, and thus all that energy can either be put into into another indoor unit, or the compressor will just ramp down to off. And so that's how you can have full and part load efficiencies. One manufacturer coined this term, personalized comfort. So personalized zone level comfort control. That's how we can look at each indoor unit. The software programming in the outdoor unit continually scans approximately 250 data points to meet predefined target temperatures and pressures. Okay, these are already written, and instead of saying software program, we could say algorithms. So what is an algorithm? Well, basically, it's just a set of instructions. If this, do that, And the best analogy I can give to that is actually it's a story. I was called out on a 8-story hotel in Dallas, Texas. It was the summer that we had over 100 days with 100 degrees, and the system wasn't keeping up. The VRF system was cooling the common areas. And so I got called out and looked at the remote control, and it said 74 degrees. So it was 74 degrees. They wanted it at 72. And it was a little uncomfortable, slightly, not like the lobby. And So we made it the way to the roof, and I saw a condenser farm of condensers, walked towards them, and as I walked towards them, I past them, and then looked from the rear, and I saw a bunch of goosenecks. Laundry vents. So as I approached the condensers, they're usually blue, but these were like a gray. And sure enough, all the lint was completely, perfectly coated over the coil. And you could just peel it off perfectly. Now imagine a typical air conditioning system coated with lint, maybe ½ inch thick. What would happen? Something, right? You wouldn't be cooling. But because of the algorithms, the software programming, the discharge temperature is monitored, and the system just lowered the compressor, increased the fan motor to maintain that discharge temperature in its happy spot, right? Which can be, somewhere between 160 and 220 degrees, depending. So was that a good kind of understanding of how the software can work? Yeah? Set of instructions. Again, just to kind of simplify it, the software is a conductor in a sophisticated symphony. There's a lot of stuff going on. It's the components applied science, and mechanical and electrical engineering. All right, so we have heat pump, and then we have heat pump with heat recovery. So with a heat pump, you have 3 general components. You have the outdoor unit, and the indoor units, and the controls. Pretty straightforward, right? You got one mode at a time, but everybody has their own control. So you have one mode at a time. Typically, first mode wins. There's a lot of strategies to manage the mode call. We're not going to go over that today, but there are. But generally speaking, first mode call wins. So if somebody gets there in the morning or turns on heat, then it's going to be heat until specific criteria is met for it to do system changeover. So a heat pump is a reverse cycle refrigeration system that provides cooling and heating from a single compressor. The reverse operation is achieved by one key component called the reversing valve. The reversing valve channels the refrigerant to be superheated or subcooled at either the indoor unit or the outdoor unit. Most of us understand that. In cool mode, the indoor unit contains superheated vapor, and the outdoor unit contains subcooled liquid. In heat mode, it's the reversed. And so here's an illustration of a very typical refrigeration system. This is not a heat pump. This is just a refrigeration system. However, the Achilles heel for a conventional heat pump system is its inability to provide heating or cooling at low outside air temperatures. Typically, the heat pump will start to have diminished capacity around 55 degrees outside air. However, VRF Technology uses the reverse cycle heat pump and supercharges it by optimizing the following. So each one of these components is monitored and manipulated by the software. Through this finely tuned refrigerant and electrical management, VRV systems are able to operate 100% capacity in either heat or cool mode at outside air temperatures ranging from -5 degrees to 115 degrees, respectively. There are other systems that can perform even greater. They were talking about a system that can do 100% cooling at -40, So these are just general numbers, Again, I'm not talking about any one specific. But when you engage a sales engineer or an HVAC designer about the VRF, you're going to want to know what its capabilities are, and then whatever that published data is, that's what the manufacturer should guarantee. Heat recovery. All VRF and VRV systems are heat pumps, okay? For heat recovery systems, there is an added component which is required for the system to provide simultaneous heating and cooling with only one outdoor unit. So you have one outdoor unit that can provide multiple indoor units, and you get simultaneous. You can have cool and heat in two different units with one outdoor unit. So that added component is here. So in a refrigeration system, during a call for cooling, the outdoor coil takes superheated saturated refrigerant gas and phase changes it to subcooled liquid, subcooling the gas into a liquid. In this process, the refrigerant gives off energy absorbed from the indoor coil during cooling, and then transfers that to the condenser coil as heated air, right? We all understand that, or we're beginning to understand that? Well, with the heat recovery system, that potential heat energy, which is normally ejected into the atmosphere, is rerouted as subcooled liquid and can either be stored or used by the heat recovery box. This rerouting of the refrigerant is achieved by a component by many names. For now, we'll just call it heat recovery box. We'll go over the different names in a later section. The heat recovery box is directly controlled by the outdoor unit. So if you have a heat recovery box, the outdoor unit, it's an extension of the outdoor unit. It contains components such as a liquid gas separator, thermistors, solenoids, ports, EEVs, and manifolds. All these components are monitored by and controlled by the software. So this is an illustration, and these are the different names that different manufacturers use, but it's the same thing. They are constructed and designed differently, but essentially they perform the same work. And they're in this category of heat recovery, there are two different styles. You have a 3-pipe system, and then you have a 2-pipe system. So you could have 2-pipe heat recovery or 3-pipe heat recovery. And there's a lot of arguments, which one is better, what have you. It really depends on the job. There's arguments for both. Both work, generally speaking, fine if you go with the top names. But there are some strong arguments that the 2-pipe heat recovery can save time and less first costs, because typically with one manufacturer in particular that I know for sure is that you can run soft copper instead from after the first connection, which soft copper is less expensive than ACR. By weight, not by foot, by weight. And it's my understanding that if you have a 3-pipe, it's all a very heavily engineered system, and they do recommend, if not require, ACR piping, which means you have a lot more potential for leaks, right? Because you have more braze connections. So, get with your designer or sales engineer before making any of those decisions. So what are the key features? You can mix and match indoor units. We're going to go over the different styles that are available for VRF. Inverter-driven scroll compressors. Scroll has been very good to our industry. It's a very robust and reliable way to pump refrigerant. And you can have up to 150% connected capacity. So connected capacity, what that is that, let's say you have a 10-ton outdoor unit. You can connect, in this case, at 150%, 15 tons of indoor unit. Now, it doesn't mean you're going to get 15 tons of energy out of it because you only have a 10-ton outdoor unit. The connected capacity of that 15 tons is going to be, that energy will be shared. Now, my personal experience is that you really don't want to go any more than maybe 10 or 12%, something like that. But you really have to know your building well to strategize what is called diversity, right? Because a building is not 100% used all the time. There's sections, people move around houses, right? In the daytime, in the nighttime, people are in the bedrooms. At nighttime, people come out. Same thing with a commercial building. So there are things that you can, some assumptions that you can put into your design. But like in Phoenix, Arizona, there's no diversity. It's just hot, So be careful. But one thing that you can have up to potentially 50 indoor units on one outdoor unit, which would make it somewhere around maybe 7,000 or 8,000 BTU indoor units. I've personally never seen that. The most I've seen is maybe 36, something like that. Average maybe 20 to 25, something between outdoor units. Remember, you're sharing that energy with the space. So the building load profile with the distributor capacity, the refrigerant energy is shared among the indoor units. So when one unit is satisfied, the other units can make use of that energy. There's also solar diversity, so typically north-facing buildings are going to require less heating, less cooling than south-facing. So there's a lot to know about your application. So there are 2 or 3 pipe systems, 2-wire digital direct control network, which is just, it could be shielded or unshielded cable, and you just daisy chain, and that's the communication system. Some manufacturers are polarized, so you have to land them at the specific terminals. Others are non-polar, so it doesn't matter. But it's all integrated. And if you've ever built up a chiller system or built up a HVAC system, you know that you need to buy all these disparate components and put them all together. One of the benefits with VRF is that it's integrated. So you get not only the heating and cooling power, but the DDC network. Integrated controls, which we'll go over, and backnet and long works. So I work on high-end homes I'm called into, and everybody wants to do Crestron or some new automated system, and more they're choosing VRF systems to marry with their home automation system. So individual zone control, flexibility in design. What's interesting about these systems is that there are ways you can manipulate the software by the use of dip switches. And there's a number of times when you can do all the preparation that you want, but when you get to the job, something has changed, and now that particular zone is not working as expected. So by using dip switches, I've got out of trouble. I've helped other people get out of trouble. Just that your conventional systems just can't do that. Not yet, anyways. The other thing about the flexibility in design is that you can choose whatever different models that are available. So in this case, in this photograph, we're looking at the one-way cassette. But as we'll go over, there are a number of heads and sizes. And then simultaneous heating and cooling. So this is a just generalization, This is not from any one manufacturer, but typically speaking, you can have, maybe a combined 3,300 feet of piping on a single system. With these vertical lifts, this is where, without practice, you can make mistakes. But luckily, we're going to talk about the selection software, and every manufacturer has some sort of selection software that can keep you out of trouble. But these are some pretty incredible lengths, wouldn't you agree? So the scale of economy, if you're looking at it in terms of roof space, to the right here we have RTUs, And these are condensers here. And this is a chiller system. This is a air-cooled chiller, water-cooled chiller, and this is 80 tons of VRF. At one time, there was a outdoor unit, and there may still be, that can of this size, of this chassis, that can fit into an elevator. And if you're doing a retrofit, that could be pretty helpful. But just to kind of understand the differences between refrigerant and air and water, you can see here by this illustration how much physical space is needed to achieve the same work. So in terms of transfer of heat abilities, refrigerant, R410A, is 10 times more, has more heat transfer than chilled water, and 190 times more heat transfer than air. Is that surprising to you? No? Yeah, everybody knew that. So the argument for reducing the total size of any building. I mean, I can't tell you, I've worked in Beverly Hills, Bel Air, Austin, Atlanta, upstate New York. They always want us to put 10 pounds of rocks into a 5-pound bag. If you're on residential, you're hard pressed if you're going to get any kind of mechanical drawings, And space is a huge concern. But with VRF, or ductless technology in general, here you can see illustrated what is required. And there is an argument that if you have a 10-story tall building, that you may be to lose and not pay for one full story of it just because of the ductwork that you're not installing. Here we have an example indoor unit that is about 8 inches tall. This is a ducted unit. Medium static, which is about 0.6 ESP. So lower structural costs. This slide is, admittingly for architects more than contractors, but just gives you kind of a dollar amount of what can be saved with VRF as your baseline. So integrated controls, like I said, 2-wire, polar or non-polarized communication bus. These integrated systems can have the potential to control pumps and parking lights and other on and off emergency lights, maybe not fire safety, but a lot of other things. So it has that opportunity built in. And then just the sound. We're used to listening to anywhere from 75 to 85 decibels, with an outdoor unit. As a matter of fact, this is at high. These indoor units, this decibel rating is at high fan, and typically there's 3 to 5 fan speeds. So at the lowest fan speed, it's probably somewhere around 20 dBs. And you can, with a couple of dip switches, you can set the outdoor unit to be somewhere in the 50s. You're reducing the capacity. All you're doing is putting a governor on the compressor, but it's possible. So energy efficient. System automatically matches the zone load, adjusts the capacity and thereby energy consumption, adjusts the compressor fan speed and compressor and fan speed, improves temperature control, resulting in more comfortable spaces. So soft starts, if you have, or if you're working with any solar people, this is one of the reasons why mini splits are so popular with them, because when you design a solar system, you're looking at all the loads, and the lock rotor induction motor is going to be a big load. Could be 30% of the load. So solar guys love us. Also for retrofit, you may not have to update the circuit breaker capacity. That's a big deal, right? Chiller versus VRF. Well, the new chiller may require more energy, right? Instead of using the existing 2-watt, they have to bring something wire. They have to bring in something more heavy duty. That's a lot of money. You may have to change the transformer. These are all just considerations. I'm not sure how many of you do sales and design, but these are some of the conversations that are happening to promote VRF. Inverter-driven compressor matches compressor speed to meet full or part load demand. If you find me repeating myself, it's because I'm trying to drive home some key points. Off the charts energy efficiency when in part load conditions. So we're all familiar with SEER ratings, right? Seasonal energy efficiency ratings. Yes? Yeah? Okay. So that is a design condition. 95 outdoor, 80 degrees dry bulb, 67 wet bulb. About 40 feet of duct and 25 feet of line length with the outdoor-indoor unit at a level plane. Now, tell me, what job have you installed with that condition? Anybody? Yeah, neither have I. I haven't seen it. I haven't done it. So when you get that SEER rating, it is a snapshot in time. Okay. So what happens when the compressor ramps down to half the hertz, right? Half the speed. What happens to the SEER rating? Does it go down? Does it stay the same? Does it go up? You tell me. Goes up. They don't necessarily publish that information on the residential side, but on the commercial side, there are some closer values, and we'll go over a couple of those. But that's why I wrote this off the charts. So with the target discharge temperatures, they ensure that the compressor has a long life, right? Because it seems to me that all the refrigerant components and proper installation and maintenance and refrigerant charging of any particular refrigeration system, whether it's a water cooler or a 10,000 a day industrial ice machine, if all those things are to spec, that the compressor is happy, And so one of the ways to discover the compressor's operating performance is managing and understanding the target discharge temperatures for that particular design. So that's where that Dallas story of this hotel came to mind. So you've probably seen this before. This is a very old kind of slide, but basically when the compressor starts, it just turns on, then room temperature starts to come down, it ramps up. It can go up to 120 hertz, delivering that refrigerant very fast to the indoor coils. Then the temperature just rides on that line. And so the compressor goes down to half the speed. And that's, little cartoon of what we're trying to promote in this space. So this concept works with single zone mini splits to VRF as well. And any inverter-driven compressor, whether it's conventional unitary systems or not. This is what we're trying to achieve and save electricity. So compressors soft start. You have a high power factor, which is good, and a low reactive factor, reactive power, which is great. Compressor capacity reduction equals lower kilowatt usage. Precise temperature control nearly eliminates wild temperature springs. So the only precise part of it is that the thermistors are fast reacting. It will sense a load change very quickly. And that could work for your disadvantage if it's installed incorrectly. For instance, if you install an indoor unit and it's a high wall unit, and a certain part of the day the sun beats on it, well, it's going to overcool, right? Because it thinks it's too hot. You have to strategize where you're going to be sensing temperature. With these systems, you can sense temperature from the indoor unit. You can sense temperature from the remote. You can have a remote sensor. So it's you have a number of choices. So in terms of the SEER rating for a commercial VRF is AHRI standard 2030. And it takes these conditions here and averages them. And this is supposed to be a swath between all like 4 different climates. So they're doing their best, but it tells a little better story than SEER rating, but it doesn't tell the whole story. And what happens when you have a simultaneous heating and cooling system, and you have both heating and equal amount of heating and equal amount of cooling being called? Well, there's system efficiencies with that. And so you have this curve here that people can design their system around their building, and then utilizing an energy model, have some kind of predictive understanding of how much money they're going to spend over the lifetime of the equipment. So I was attending an ASHRAE luncheon. They have them once a month, and they had a panel. This is like 10 years ago. A panel of a bunch of Texas contractors. And one thing that stood out to me is this statement here. So Mitsubishi, that's my first manufacturer call out because it's the only one that I know for sure. They published that they have a 0.5% warranty return rate. I mean, that's what they tell people. But if it's installed correctly, it's bulletproof, and that's from one of the largest Texas contractors. So life cycle, it's very much lower life cycle costs are much more achieved with VRF. Why? The cost of HVAC system is more than just the cost of design, equipment, and installation. You got to consider the operation, the service, the maintenance, and replacement as part of the total cost. VRF zone systems are more efficient, easier design, takes less time to install, and require less maintenance. And in our service and maintenance section, you'll see why. So how do they work? It's called a block diagram, typically used for designing controls. So you have the indoor unit, and you have the remote controller set point. So it's not a thermostat, it's a remote controller. A remote controller does much, much more than a thermostat. Thermostat's a 24-volt on-off device, typically. And a remote controller can control vanes, can port air messages, air codes. It does a lot more than just a typical thermostat. But now that we understand what the difference is, we can call it thermostat. That's fine. So you set the set point, and then you have the space air temperature, and that delta, that's what drives the system. Then you have the outdoor unit. So the outdoor unit, and this is for many multi-zones as well, single-phase multi-zones. It's looking at the connected capacity, thermistor readings, the compressor hertz. Could have multiple compressors, and the LEV positions, and it's targeting temperatures and pressures that it's trying to achieve. Is that a pretty good, simplified way of understanding? Any questions? Sir, I'm sorry, the light is shining in my eye.
I think the VRF equipment's really cool, but what about like control boards and stuff like that in harsh environments, the outdoor drive, all of the goodies that make it VRF?
You're talking like in an industrial area or?
Residential
Residential? Yeah. So okay, I'm glad you said beach, because the salt content of the air is going to destroy, a lot of things, right? I mean, so what I would recommend is that, they clean the coils once a month with fresh water only, because the coil already has a film on it. And then as far as the controls, you can pot the controls, the PCB, and potting the board means that you're just putting like a paste on there, a silicone, and you have to remove it and then pot the back of it, put it in the front, and you can put some in the front too. But, there's not a lot more you can do without, yeah. Yeah, but what I find interesting is that the installers, when they put in a system and they run the line sets, they don't cover that penetration well enough. And so you get all kinds of critters and things. And so, and yes.
So what I've noticed, because I've traveled overseas for years,
Yeah.
that in Korea, Japan, China, their manufacturers over there, coastal companies, they sell to island companies, they have a line that they don't import to the United States that have a saltwater rated coating on their film. It's usually black or it's a heavier film.
Yes.
And I guess because of cost in our market and our capitalism, whatever, they don't sell it here because it would up the price too much.
Well, yeah, they also don't have UL, so there's a lot of differences.
So they'll have units that will last
But
right on the coast where our units.
you can get that. Thank you for bringing that up.
You can have that done.
You can, yeah,
Do it with Gulf Coast.
yes.
If I have a quite a salt, I'll take it apart, go
Yeah.
strip it, de-wax it, degrease it, let it dry, and then I'll put 2 or 3 coats of epoxy on the whole thing.
Yeah, and some manufacturers will sell you that coating, but you're adding additional time because it's going to be a special order, yeah, and cost. So you can also coat the coils. There's like an epoxy. You have to take out, disassemble the coil and dip it is the proper way. If you spray it on, it's going to last maybe 2 or 3 years. So you have to come back and retreat it, which may be a maintenance contract. I don't know. But if you dip it, it's going to last a lot longer.
When you're using a sealing cassette, you have to worry about the heat in the attic, in the crawl space?
There is a foam that's about maybe an inch thick on there, and I haven't seen them sweat, so I would say no, you don't have to worry about that. Yeah.
Is there tricks or do's and don'ts to bringing in fresh air?
Well, yes. This is a rabbit hole. Who wants to talk about fresh air? Show of hands. You got 1, 2, 3. All right, we got enough. All right. So that has nothing to do with fresh air. I didn't include fresh air is because it's a half-hour minimum to an hour conversation. But my recommendation, based on my experience, design experience, and project experience, would say you're probably better off with a separate ventilation system. You absolutely got to be careful because I'll give you an example. If this is a cassette, okay, and I'm looking at the top of it, and here's the bottom, there's going to be one side that's going to have the incoming vent, right? It's going to be 4-inch or 5-inch, something like that. Now, let's say that's raw air, right? It's filtered. There's like some MERV 8 filter somewhere, and it's not drawing it in. It has to be powered in. And now this connection here, we don't know where the pipe sensors are, but that part of the coil is going to behave and react differently than the rest of the coil. So it isn't evenly distributed. Because in a cassette, the coil wraps around, right? Now, if you have a ducted unit, right, and you have a return air duct, you can install the outside air, ventilation air in the duct, and it, depending, it may just be on one side of the coil, But what if that side of the coil is in part load conditions, you know? So you see where I'm getting? You know, you can have too much air coming in, too much temperature, high temperature, and the system is not going to respond well. Or if it's in part load, then it may respond great in full load conditions, but in part load, it may not take care of the air treatment that you need. So I always recommend, you know, if you can afford it, on a residential or a light commercial, you know, get a dedicated dehumidifier, you know, like April Air or Santa Fe, something of that nature. Pre-treat it before introducing it into the air conditioning system. Or if you're a commercial, then it would be like an ERV or a dedicated outdoor air system. So basically, this is just a very high overview of the electrical system. And from the top left to right, you have AC to DC and DC to AC, right? That's the inverter section. So the AC voltage gets transformed into DC voltage. It's manipulated. Then it's converted from DC to AC. Once the voltage is controlled by the software, the voltage frequency, which in the US is 60 cycles per second or 60 hertz, can either be increased or decreased to suit the demand. So fun fact, nearly all, if not all, single zone ductless mini splits are three-phase compressors. Who knew that? Single zone, fun fact, this is a single zone ductless mini split, are typically, all of them are three-phase compressors. So yeah, one of the lines is a simulated third leg. So, you know, in the history of electricity and electronics, a tremendous amount of manipulation has been part of it. I mean, it's electricity is just amazing, and I highly recommend, if you plan on staying in this industry for more than 5 years, that you learn computer terminology and electronic terminology, because you're going to have to interface at some point with a system, and if you don't understand the words or why they're there or what's going on, you know, it can cost you time and money and maybe even the customer's confidence. I've seen it a lot. So that's my recommendation for the day.
As far as treating the control boards, can you just use like any kind of caulking?
No, sir.
What's the special?
So I know I could say this with some confidence that whatever manufacturer that you're working on, okay, so Trane is Mitsubishi, and I know for a fact that they have a recommended tube of silicone that, I don't know if you can buy it from them, but I've replaced boards before and it came with it in the box.
Yeah, the white paste that goes with your liquid.
This was clear, but the white paste is the heat sink paste. Yeah, I think that's different. I always, you know, even if I'm sure, I always like to use whatever the manufacturer represents, right? I'll improvise on things that have a very low probability of coming back at me, you know? So, yeah, get with the manufacturer, but, question? Sir?
With all this interconnecting copper and electronics, do you have to worry about lightning strikes?
Always.
But I mean, like, more than normal.
No. No, if, what Florida is the most lightning, okay, in the US. So lightning strikes, so I've worked on 2 hotels with lightning strikes, and it's, there is no rhyme or reason what happens to the components in a lightning strike. We've had This particular project I'm thinking of had 8 systems, so they had 8 outdoor units, and it's a 4-story hotel, and every room had either nothing wrong with it or something different wrong with it. So it wasn't like a very, it took that contractor 2 months to fix it. They had to shut down for about 6 weeks, you know. But, you know, had they had some lightning arresting apparatus, or perhaps maybe even a surge protector, which is not the end-all be-all by no means, but it's better than nothing, they could have saved some trouble perhaps. But I have not seen or heard, you know, in all my travels, that VRF is any more or less susceptible or will cause an increase of lightning strikes. All right, so PID. You know, PID's been around for decades. Manufacturers of whatever widget, you know, food manufacturers, car manufacturers, you know, component manufacturers have used PID in getting their work done. A lot of people use the analogy of a gas pedal. So you have, and forgive me if I get this wrong, but it should tell the story, is that you have the gas pedal itself, which has a mechanism. Then you have the pressure of your foot, right? And then you have the resistance. So all those things are accounted for in PID, let's just say. And so when you look at service manuals, or you're seeing T1, T2, or T-set, or what have you, you know, it's part of the kind of language. And don't get thrown off by it. It's just an engineering way of communicating what to expect, you know. Because remember, an algorithm is a set of instructions to solve a problem. Here's a breakdown of a expansion valve. You have typically a 12-volt power head, 12-volt DC power head. You have the valve body. The stepper motor can go 500 steps or 2,000 steps, depending on what it's doing, how big the system is, where it is applied. So, you know, if you think about a thermal expansion valve, you know, it's very slow responding and not very finite in its control. Would you agree with that statement? So with a stepper motor, you just have much more control. Then you have what can be referred to as a smart coil. So some coils have up to 3 sensors in them: an inlet, an outlet, and then a room temperature sensor that's constantly monitoring to keep target superheat or subcooling in line. Key word here is target. And this, yes, sir. No, not like a regular heat pump. It's much more refined. Depending on the manufacturer, you can have a timed defrost. That's every 8 hours. Some manufacturers will just look at the coil and says, we're a little frosty here. Let's go to defrost, and it can be anywhere from 2 minutes to 4 minutes. So I don't need to be snooty with your question, but yes. So the indoor coil fan stops. Yeah. The system is very intelligent. If you want to turn this conversation into what happens when you first start it, say if you have 20 degrees outside, you don't want to blow cold, right? So the system will increase the compressor speed, which can heat up the refrigerant before it's delivered to the space. And at a certain threshold, then the indoor fan will turn on. So at the get-go, you're blowing warm air. All right, so let's go over the components. We have air and water source heat pumps, hybrid VRF, which is already available overseas. They've been talking about it for 5 years or more, bringing it here. Heat recovery systems, indoor fan, coils, indoor units, zone control, central control. All right. So typically you have an outdoor system that can be anywhere from 6 to 36 tons. Some manufacturers even have larger combined units. Somewhere the voltage 208, 230, or 460 volt, inverter-driven scroll compressors. Sound ratings as low as 48 decibels. Connected units 50 to 1. And connect up to 130% of indoor unit capacity. You may notice, those who are paying attention, that I'm changing these numbers. It's intentionally. I'm not trying to be consistent, because you need to go out and whatever unit you're going to apply, that's what you should be looking up. If you're designing a system based on this presentation, you're going to get in deep trouble. Right? This is just all the introduction, right? Essentials. Single phase heat pumps are available in 3, 4, 4.5, 5, and 6 tons. There's one manufacturer I know is making a 6-ton single phase VRF. So 230 volt single phase typically. I'm sorry? Inverter-driven compressors and 12 to 1. Now there is one manufacturer out there that makes a single phase heat recovery. So now any of you guys working on residential and you want to put in something real fancy that can delight, the most, demanding of customer, maybe this is your product. Then we have water source heat pumps and heat recovery. Most major manufacturers have this product available. So you can imagine that you have a water system, and instead of running it through your chiller and boiler, you just run it through the VRF. And if you have a ground source heat exchanger, otherwise known as geothermal, you can do that as well. Then you have what is touted as hybrid VRF, which is basically using both water and refrigerant. The green here in the illustration is refrigerant, and then you have that heat recovery box can produce either cool, chilled water or hot water. So the heat recovery box. This is a illustration of just one of the manufacturers that are available out there. Here's another illustration of a different one. They come in different sizes. You can have 1 or up to 16 indoor units connected. Here's project. You can tell it's installed with 0 clearance at the top. I'm not saying that that's recommended, but you want to read the installation manuals for your prescribed clearances. And this is what that particular indoor heat recovery box looks like inside. You have a tube-and-tube heat exchanger here, your solenoid valves going to your ports, and your manifold block here. Then you have your LAV and its sensors. I would advise that you don't be intimidated by this, because these are, there's a lot of people that have been doing this a long time, good people that can help you get out of trouble. And, it's just, at the end of the day, it's just a man-made device that does something pretty cool. And if it's made by man, then it can be fixed by man. Here's a very top level illustration of different heat recovery box strategies. In this case, you could have 16 indoor units with 4 boxes, heat recovery boxes. You could have 1-to-1s, or you could have many-to-1 indoor units. All right, so you have the classic high wall mount. Ceiling suspended, and the ceiling suspended, the return is the bottom, and the supply is this vein here. And you can have 0 clearance at the top, and it has a very long throw, maybe 33 feet. So if you have a narrow space, this is a great solution, for maybe schools or IT room. I'm not recommending VRF or IT or VRF or ductless for crack rooms, computer room air conditioning. But it's going to get done whether or not I recommend it. But this with a long room and it has a high heat load, if you throw the air across, then it will come back hot. And now you are cycling that, you're removing that heat from the space, So if somebody's dead set on putting a VRF or a ductless in a computer room, this is the one that you may want to look at, especially if it's a long room. Then the floor standing, these are great for radiator replacements. So in the northeast corridor of the United States is our number one, is VRF and ductless number one market, because they have very old buildings with no attics, and these are very popular there. Also with churches, you can put some of these, you can get a floor standing without the cover and install it into a wall. And some, you can put short ducts on there, depending on the product, so it can be hidden in the wall. And if you imagine a church, that has a lot of expensive millwork, they don't want something sticking out, so you put it in the wall and do, get very good, aesthetically pleasing application. Then you have, this is a 4x4, 3x3 four-way cassette. And here's a 2x2 four-way cassette. So you can throw this in a T-bar ceiling, half of a T-bar ceiling. This guy's pretty big. So if your ceiling height is anything less than 10 feet, you may want to go to this just because it's pretty big. And then the one-way cassette, which is great. And when I get a VRF in my house, I'm using all the one-way cassettes. Now these all have built-in drain pumps. Typically, these do not have built-in drain pumps. You have to add it after. But these have built-in drain pumps. And ductless means no ductwork. For all these reasons. No testing and balancing. There's ducted systems, medium static, low profile, low static, and then the conventional, a classic air handling unit. So you have a centralized controller that groups zones together all in one interface. So maybe you have 250 indoor units, 256 indoor units, but with a web browser, you can have up to 2,000 units all in one computer. So the number one thing that you should remember about service, the most important thing when you are approaching a system is you have to have patience. All right? If you've never worked on these systems before, you're going to need, if you think it's going to take an hour, schedule 3. Also, get the manuals. The manuals are your key roadmap. You're going to need a DC voltmeter with 600K ohms. If you're working on VRF, you're going to need a computer because you're going to be interfacing with the computer. Some service tools are better looking than others. This is just an example. And please leave your gauges in your truck. Please leave your gauges in the truck. Don't bring your, for VRF or ductless, really, leave your gauges. You can't control the superheated soap cooling, so I don't know what you're looking at. Here are the players. Names you know. These are the main players, in my opinion. And 5 years from now, there's probably going to be Chinese names here. Well, thank you very much for your time.
Thanks for watching this video. Again, to find out everything we have going on, you can download the free HVAC School app on Android or on iPhone, or go to hvacrschool.com. And then specifically up in the top, you'll see events to find out more about upcoming symposiums. Hope to see you there.
Thanks for watching our video. If you enjoyed it and got something out of it, if you wouldn't mind hitting the thumbs up button to like the video, subscribe to the channel, and click the notifications bell to be notified when new videos come out. HVAC School is far more than a YouTube channel. You can find out more by going to hvacrschool.com, which is our website and hub for all of our content, including tech tips, videos, podcasts, and so much more. You can also subscribe to the podcast on any podcast app of your choosing. You can also join our Facebook group if you want to weigh in on the conversation yourself. Thanks again for watching.